Hi, I'm Nick with DuramaxTuner.com. Right now I'm behind the wheel of our 2004 Duraburb, a truck with over 1,000 wheel horsepower. This is one of our most popular projects. It includes a lot of cool new cutting-edge parts, including Exergy's 14mm pump, our Stealth 64, 150% over injectors, and of course that Borg-Warner S488 SXE. Man, listen to that thing. It is just nasty. Remember, we're not just a tuning shop. We're a specialty high-performance shop capable of starting your build and finishing it, taking whatever horsepower number you're looking for and putting together a drivable, succinct, reliable combination of parts. You can get in contact with us at 815-568-7920. Again, that's 815-568-7920. I'm Nick Priegnitz.
Hey guys, this is Paul. Really wanted to say I'm excited about Ohio corn and wheatgrass growers now partnering up with Calibrated Power. This means if you go ahead and sign up for their 3-year membership, you'll get a 10% discount on any of the Calibrated Power or Duramax tuner tuning products. Of course, you can always call me to ask more details about this. I'm available at 815-568-7920, extension 2122.
The Diesel Performance Podcast contains explicit language.
Thank you for joining us again. This is Paul Wilson.
And I'm Danny Voss.
And Nick Priegnitz.
And you're listening to the Diesel Performance Podcast. Guys, some killer episodes here lately, huh?
You guys have been killing it, Paul.
It's just been insane, the amount of customer feedback, the amount of comments on Facebook, and of course all the downloads. Guys, we do want to stop and say thank you so much. Thank you for rating us on iTunes. We really appreciate that stuff. Make sure you subscribe to the channel.
Go to YouTube and also make a comment on one of the videos.
Absolutely. And of course, some of our recent episodes, if you guys haven't checked them out, you want to check out Gale Banks Part 1.
Definitely check that out.
That's probably the best episode we've done. We're going to be continuing Gale Banks Part 2. And of course, if you missed it, we are now the official podcast of the Ultimate Call-Out Challenge.
Calling it out.
That is so cool for Danny and I. We're so excited.
We get to meet a lot of neat people that weekend.
Absolutely. We had Randy on the show. He had some great insight for us, gave us some really good feedback, some insight into the UCC. And I did mean Brandon when I said Randy. That's my bad.
You guys are going to be talking to a lot of guys with broken trucks this year.
That's okay.
I like it. We should get Rich going on a video log of all the broken shit we see at UCC.
Mm-hmm. That'd be entertaining.
Get your tickets. Get your room booked. Yep. April 21st, 22nd, and 23rd.
Danny's got it down. Do we got rooms yet, Nick?
Diana?
Nick does not handle booking rooms, in case anybody was wondering.
There's a huge fireman convention that weekend, so there's going to be like 50,000 firemen floating around the town.
I was going to say, how many huge firemen can there be in one town?
Yeah. Future episodes, we're going to be doing modified injectors, talk to some interesting guests that we're going to be having on. We'll be announcing that as soon as Danny and I actually write up an outline for it. And, of course, check out the Diesel Tuners blog. We're really excited, guys. Read all the articles. Danny and I have been trying to publish as much as we can there. Try to get out an article or two a week about diesel stuff.
I must say the quality of the content there has been improving nicely. I like it.
Thank you.
Solid, good read.
Yeah, some of it.
Don't read our first blogs.
Right, don't go back to the old stuff.
But, like you said, they keep getting better and better. Kind of like the podcast.
Yeah, absolutely. Guys, today I'm so excited. We have Gale Banks back on the phone. Gale, how are you today?
I'm doing good today. Thank you.
Absolutely. We're so excited to get you back on. The comments we're getting back on Facebook based off of your first episode were just awesome. So many guys with a ton of questions about the L5P, I think is probably our biggest kind of query there.
Absolutely.
Sure.
And then, of course, we talked about wanting to get into talking or discussing dynos a little bit further and mad versus bad if we have some time here. So I thought we'd roll out. I did a little research. I know you were scared about scooping GM. I did find GMauthority.com currently has the L5P listed 445 horsepower, 900 foot-pounds of torque. So that's at least 910. That's what they're rating it at.
Since I've been involved with the development of the engine, and not just the L5P, but our relationship with GM on this engine family started about 2004, and with the LLY at that time. The whole thing came out of us doing it actually came out of a race venture that we did.
The LLY did?
Yeah, it came out of a Cummins deal that I did. I mean, we may have talked about in the last podcast. The record that we set at Bonneville with that at 222 was our best mile. The Navy wanted to develop a new diesel marine engine for special forces use, and they were looking at the Cummins and others, and read an article. We got a lot of press on that Dakota. It was massive press. They read an article somewhere, and their power number was 700 horsepower, and their torque number was like 1,050 pound-feet. And it had to go through a really rigorous test procedure, 800-hour test at 85% of which is at wide open throttle. And we talked about this last time, and Navy got a hold of me and said, we want to build a marine engine. Can you base a marine engine off that record engine in the truck? And then I said, yeah. But having decades and decades now, coming on 60 years experience building marine engines, I knew this was a lot harder test than building something to drag race or to do a 20-second or so truck pull.
Sure.
In other words, 800 hours is 33 days of dyno. You need a good dyno to go 33 days.
Yeah, wear a dyno out before
By
an
the
engine,
way,
right?
you don't do that on a something that normally does a 3-second sweep.
Yeah.
So we went to Texas to Southwest Research Institute and met there all the what you call stakeholders in the deal on this marine engine, and we tore down a Duramax and a Cummins and laid them out on tables. And if you looked at the components, you kind of, the Duramax was highly reminiscent of a lot of big block Chevy stuff I had done in the past.
Sure.
And the Cummins was what it was. It was originally a tractor engine. The 5.9 was a joint venture, kind of, between Cummins and J.I. Case. And the last time I looked at one of the cylinder blocks, the tractor mounting provisions were still there. The thing originally was going to be, I don't know, I'll take a wild guess, 135 horsepower.
Sure, yeah, it's a cast iron dyno.
Being out in the field doing work, which they did. This thing's come a long ways. I mean, the Cummins come a long ways, but the parts, just the connecting rods, when you compared the connecting rods, whether it was, you looked at the Cummins part and you went, durability plus, and what turned out not to be durable was the block itself. And in other words, to make that kind of power and make it for 800 hours, that would be a double NATO test. A NATO test is normally 400 hours. You had to, you're upping the cylinder pressure, and you're doing it for 33 days. Mm-hmm. So what we found, close to 300 hours in, as I recall, it was the number 3 and the number 5 cylinders. We were tearing the deck off the top of the cylinder. By that I mean, at the top of the water jacket, a crack formed into the cylinder. So when you viewed it in the cylinder, it was this crack of about 3/8 of an inch down the bore that went horizontally around. And when that crack occurred, well, then now you're blowing combustion into the water jacket and water into the cylinder. What happened was it's the cycling of cylinder pressure over about 300 hours at or near 700 horsepower or over 1,000 pound-feet of torque, tore the top off the block.
Jesus.
Now you have to understand, if the original power output intent was 130 to 150 horsepower, let's say, we were, way beyond that. It's like 4 or 5 times the design horsepower of the cylinder block. So these things are to be expected. We sawed one of the blocks in half, and we discovered it at the top of the water jacket. The foundry core that was used to form the water jacket had a square corner. In other words, no radius, which added to the problem. So we got the guys in, I think those were ran down in Brazil, those castings. Got the guys in the foundry to hand file those cores and put radius at the top of the water jacket, inside the water jacket. That radius would be progressing from the cylinder wall to the underside of the cylinder deck.
Just to give you a little bit more.
And those blocks lasted, once again, now the numbers are fuzzy, but it got us closer to 500 hours. So it was a good move, but still no cigar. They still failed in the same place ultimately. So compacted graphite iron, CGI, was coming online back then and being used quite a bit in Europe for high output gasoline and for diesel. So they poured 50 CGI blocks. The guys at Cummins hadn't had any experience at that point. As I recall, they sent the blocks over to Case or somebody like that to get them machined. Somebody who was already doing CGI. And the first two, the cylinder walls got kind of screwed up a little. I still have those blocks. You could do a cleanup bore and run them. I never have. But the compacted graphite block did the deed, made it happen. So everybody was happy. Turned out to be a good marine engine. To my knowledge, they're deployed all over the world, and just a real fun time to do another marine engine, especially a diesel at that time. And oh, by the way, we're going to do a marine version of the L5P.
Oh, really?
Oh my God, I'm pumped out of my mind just thinking about it.
That is awesome.
More horsepower when you go to the marine application then?
Well, a while back, I did a super turbo version of LMM, the LMM-based marine engine.
Yeah, we saw that with the screw blower on it and the turbocharger.
Yeah. I used a screw blower and 2 turbos. In fact, no, check that. I used the 2300 rotating group, the Eaton, that they use on the most badass Corvettes and what have you, or were using. They've now got a little more refined version of the same blower.
Yeah.
But we used a 2300 and then a pair of, so it was a compound. The blower and the turbos were compounded in series.
Right.
So to speak.
Yep.
Pretty good deal. With conventional turbocharged marine engines, it's like driving out of the hole in overdrive. No, in other words, you put the truck in 6th if you have a manual transmission, and then try to drive away with a full load in a trailer.
Now, there's a true spool-up test, right?
That's kind of, yeah. It's the worst spool-up situation you could possibly imagine. These boats have no transmissions.
Right.
It's not that they couldn't have transmission. We were putting C6 automatics in twin turbocharged ski boats out here 35, 40 years ago. So putting an automatic in a boat is not a new subject. But
Right.
when you put the kind of torque output that we were doing, it killed the automatic transmission.
Well, can I
So-
ask why not just run a compound set of turbos instead of a turbo to blower when you're in the marine application? Like, what was the benefit of the blower as opposed to just having two turbos?
Positive displacement. I can set the blower overdrive such that, turbos are centrifugal compressors.
Right.
Roots or the Eaton version of the Roots, or especially screw blowers, give you pressure. I mean, we have boosted idle in the boat.
Yeah. I mean,
Gotcha.
he's really turning a 400 cubic inch engine into a 600 cubic inch engine.
Yeah, I actually set up the overdrive. We finally resolved the boosted. You can get too much boosted idle. By that I mean the air-fuel ratio in the diesel is so lean that the engine just shuts off. I mean, you're still injecting fuel, mind you, but so I had excess air at idle. We set up a valve mechanism to vent off boost air at idle.
Okay.
And we're doing that in our dragster as well as the dragster program evolves. I'm going to use the L5P for the dragster program. I got two long cars. I got a top dragster, which is like a 278-inch wheelbase, slip joint Spitzer car, and also I've got a streamliner. Which was a hardtail. We're putting rear suspension in the streamliner right now. This is a Bonneville car.
Right.
The car's been 382 with 1,200 horsepower in it. It's incredibly. It's like the profile of a streamlined motorcycle, Bonneville motorcycle, a little bit wider, and an extra wheel at each end. In other words, the track width of this car is about the width of an engine, or your shoulders.
Yeah.
If you're a weightlifter, maybe it's the width of your shoulders. The whole deal is that the English have the record at 350. The JCB car, which was a 2-engine all-wheel drive setup, and the engines were following the architecture of the JCB industrial engine, but Ricardo, an English company that designs engines and other powertrain items, Ricardo did a racing engine version of it. So you have 10 liters of 5 liters front, 5 liters rear of pure race motor.
Jesus.
They went 350. That's their world record for diesel at Bonneville. Well, I've got a little streamliner that's been 380. I think with the L5P based setup and the right cylinder heads, which will probably come from a young man in southern Indiana who's gaining fame for his cylinder heads.
I assume you're talking about Wagler Performance there.
I was going to say in
Hell
a big
yeah.
way, especially after SEMA, huh?
Yeah. Jeremy's a very cool, inventive young man.
Mm-hmm.
Good friend. So, in fact, he's gifted me with a set of heads for the dragster program. Unfortunately, they won't bolt to the. I need 2 more head bolts.
Yeah, that was our question there, is how does that work on the L5P? I thought there was some different architecture
Well, I could make it work. I'd love to have the 2 corner head bolts. That, there's 2 more head bolts on an L5P than any previous engine.
there. Okay. 2
so-
per head or 1 on each?
1 on each end of each head.
Okay.
They're the upper row of the smaller bolts.
Okay.
There were none on the ends of the cylinder head. There are now bolts there.
Gotcha.
So we're going for 400, but my car's a hot rod. It's just, in fact, when it went 382, it had a 53 DeSoto in it, which is a little Hemi version of the bigger Chrysler at the time. So cast iron heads, cast iron block, 1271 blower, and a dose of nitro over alcohol.
And you went how fast in that?
382.
Whew.
So
one L5P in this Bonneville car, or two?
Yeah, it'd be the same layout. And in fact, the thing had a non-locking torque converter and a turbo hydro behind the little Hemi. Turned the Hemi 8,800 RPM.
Yeah.
So Charlie Markley did the engine. And the Markley brothers are legendary at Bonneville with those older Chryslers. They're just cool guys.
It's a cool engine.
So, wasn't a Banks engine at all. Basically, I inherited the car from Hoffman and Markley, the guys that were running it back in the day, and I'm actually pretty much threw the chassis away. It just wasn't, the torque I want to put through the chassis is now much higher, and
you're talking
I
half
want
the RPM there.
Yeah, and the roll cage. I'm changing everything, but the bottom line is, I'm not changing the external shape of the car, except for a little nuance on the nose. It had about 1/4 of an inch of nose lift above about 350 miles an hour. I don't want any nose lift. If anything, I want it to press down slightly. So we're changing the nose to affect that aerodynamically.
Nice.
And anyhow, I want to go 400 with a diesel. I want to do it with a hot rod, 2-wheel drive, single engine, a basic hot rod diesel built to last 5 miles at wide open throttle, and then doing it at world record, you've got to turn around within 1 hour and come back.
Back it up.
So it's 10 miles of wide open throttle within an hour.
Oh, so like a normal daily drive to work. Gotcha.
Yeah.
No big deal. Hey, after a quick word from our sponsor, Gale, we're going to ask you some more questions about the L5P motor and really dive into the dyno stuff. We'll be right back.
You got it.
We want to give Nick Priegnitz from Calibrated Power a chance to tell you more about custom tractor tuning. If you operate a farm or know someone who does, we think you're going to like what he has to say.
We've been talking a lot about our tractor calibrations lately, and it's for a very good reason. We're helping farmers like Warren Newman of Winnebago, Illinois realize that upgrading through Calibrated Power's tuning makes sense for any operation where the bottom line matters. And you can get these same results for yourself with our Power Manager. In just minutes, you can tune your tractor. There's no downtime, no labor charge like with some of our competitors' products. It's easy to install, but that's not the whole story. Our tractor calibrations work within the manufacturer's powertrain specifications, so unlike our competitors, we don't fool the tractor's computer. It still has full control over the fuel usage and can accurately track fuel usage during operation. Our tuning method delivers calibrated power. The message is in our name. For a given fuel rate, there's an appropriate amount of boost, appropriate amount of timing, fuel pressure, pilot injection, and emission systems performance. When you're using our competitors' products that are simply adding fuel to the mix, you don't get those benefits. You don't get the extra boost, you don't get the extra timing. So you run into long-term reliability issues, piston failures, emission systems failures. There's a reason that the factory uses a calibration to upgrade a tractor through the series. It's because it's the most effective way at managing the combustion parameters, period. For Warren Newman, it means operating in a higher gear, more than 1 mile an hour faster, and in a lower rev range. That's efficiency that you can see in action.
Well, I used to burn over 1/2 gallon to the acre, and now I'm burning about 1/3 of a gallon to the acre. So it's made a big change. I mean, you do 300 acres in a day, and you burn, not quite 1/4, but, that makes a lot of difference.
Unlike hardware modifications, our calibrations can be easily removed, and the stock calibration can be restored with a simple reflash. Our calibrations have the potential to help any operation with a tractor under load, save money and time. Give us a call today and ask about our tractor tunes and see how they can make a difference in your farming operation. 815-568-7920.
The king of carb is on the show today, Paul.
Absolutely. Gale Banks, we're back here with you and Nick, and we were just talking about the L5P. 400 miles an hour is the new goal for top speed record.
I mean, the man's got to have some faith in the block here. You know, you were talking about the Cummins test and about the NATO test and about this thing holding up. I mean, it sounds like the L5P is your weapon of choice moving forward here, Gale.
Yeah, you know, actually, we're going to take some laps. The engine program will be the same for our dragster as for Bonneville. Now, normally, I wouldn't do that. What I need is a top dragster that runs low sixes.
Everybody
I think,
needs that.
Yeah, right. Yeah, just low sixes. Yeah, he's not great.
Well, you know, what's that cat's name out of Indianapolis? It does a really wicked Cummins engines.
The Scheid diesel.
Yeah.
Mm-hmm.
Yeah, Dan Scheid.
Yep.
Good guy. I've talked to him about match racing. He's up for it.
Really?
You know, yeah. Run the Duramax against the Cummins.
That
It's
I would
like
pay to
Chevy
go
and-
see.
It's like Chevy and Ford.
There you go. There you go.
You know, it's what the hell.
It's a classic battle.
So you're talking about a 6-second pass here with the L5P in this long wheelbase
Yeah.
car against Dan Scheid, and then
Yeah,
you're talking about a
and,
10-mile, 5-mile run with the Bonneville deal.
Yeah, what's the difference is the cooling the pistons
Right.
is the big deal. And normally in a drag race engine, I wouldn't be running a gallery-cooled piston, but in this case, I would be because I need a gallery. The level I want to push the engine, you know, it's still around 7 liters, and I want to push real hard. So the gallery-cooled piston thing is it's either going to be that. You know, you can't do a forged piston with gallery cooling unless you do it in 2 pieces and then electron beam weld it together and then machine it. That's possible. I've also got some pistons, some cats in England made for me that are gallery cooled forgings done a different way. But
Don't you want to fail? Don't you want to fail the standard piston first and see?
See what's the limit?
See how far you can push this thing.
well, I intend to do that. Yeah.
That was one of the coolest videos I think we ever watched was H&S Breaking Point when they blew up that LML. I mean, they did it in the least scientific way I've ever seen done, but it was cool to see them push it, you know.
Yeah.
Well, I've always looked at engine development kind of like a guy who is a test pilot in a fighter aircraft. You go out and you find the limits, you find the envelope, and then you fly within that envelope. Same thing goes for engine development. I want to know coolant temperature failure. I want to know oil starvation failure points. I want to know piston temperature failure points. There's a lot of things you want to know, but my view on engine modification, if it doesn't fail, don't replace it. There's lots of guys who buy parts because they don't know where that is or aren't aware that you can go a long ways with stock parts.
Preach on.
We love that mentality. I mean, the factory spends a lot of time engineering parts and running them through the development cycles, and I mean, we should be the beneficiaries.
There's overhead designed into that stuff. They don't run right at the limit.
Right.
You know, I've seen a Duramax engine that came in back into the plant. There's a guy running a hotshot truck, you know, a 1-ton dually, pulling a trailer with 3 vehicles on it, going across country. He had 980,000 miles on the engine when the guys in Duramax learned of this guy. They offered him a free new engine if they could take his engine and dyno it and examine it. And I was there Marine when they tore it down. I mean, there were still hone marks in the cylinders. They dynoed it first, and it made the same torque that it made at the end of the production line when it was new. And it was down a bit on horsepower, probably due to the valve sealing. But this engine had not been remanufactured. It went damn near 1 million miles.
Was it an LBZ?
That's overhead. That's design overhead.
Design overhead. Use that term, guys.
Yeah,
Not everybody can do that, but this guy was really scrupulous with oil changes, filtration changes, all of that.
Yeah, we
And
see that.
yeah, he'd done some injectors and he'd done a pump. You know, I'm talking about the base engine.
Right.
But there's overheads. And I think there's going to be a lot of overhead in the L5P. The pistons have, prior to machining, they do a laser remelt of the lip around the combustion bowl. If you will, the radius from the bowl into the deck of the piston.
Wow.
You know, the top surface.
Yeah.
And by doing that, you know, that's a place where
Very common failure point.
where you get real eager with injection and you get your cylinder temperature. You know, guys look at EGT. Well, EGT is just an indication of what happened in the cylinder.
Right.
It's just a lower value of that same process. And so this makes that rim more resistant to melt. And then, you know, there's injector targeting. There's a lot of nuance to this, but I still like the idea of a steel piston. But I'm not designing an engine in a racer or a boat to go the equivalent of 200,000 or 300,000 miles. And I think the guys that designed this engine were thinking of that and much more. The thing is really, starting with a crankshaft,
Yeah,
I
it's a
did
monster.
finish with the prior subject, didn't I? Because I'm moving to L5P away from the race application right now.
No,
Is that okay?
Yeah,
please.
You know, they overlap.
Okay, so basically the engine design, the original engine design was for a peak firing pressure. Well, I'll speak to LMM and LML. Peak firing pressure of around 150 bar. This new engine is a 180 bar design. So it's designed for 20% higher peak firing pressure. Now, to achieve that pressure, you've got to have more energy in the cylinder to produce it, which means greater heat rejection, greater heat generated during the process, greater energy might be a better way of saying it. So here you've got this engine from a thermal standpoint, a lot more water pump. I'm talking about the coolant water pump. Same impeller diameter, but much deeper veins on the pump. While I'm there, might as well talk about the oil pump. That's quite a bit more. There is quite a bit more oil pump. The piston cooling nozzles are, by some strange coincidence, and I don't want you guys to get the idea that I fed any ideas to the design group at GM. Everything they did on their own. Okay.
Put that in the header, Rich.
We talked back and forth, but they didn't divulge anything to me that they were doing, and that's how it. Until I had a beta engine, and then it was all divulged.
Right.
So did we get more oil cooling capacity?
How's that?
Did we get more cooling capacity on the squirters? Did we get more,
Yeah, they're the size we were using in our racing engines prior.
Really?
Yeah. And what I like to do for marine is they have check valves in them. I don't know if you guys have seen, and the check valve effectively is a flow restrictor. And the nozzle pressure, the oil pressure at the nozzle tip is the engine oil pressure minus the check valve cracking point. So we remove the check valves. Well, if you do that, then your idle oil pressure kind of tanks.
Right.
Now, they do have more oil pump. There's more oil pump in these things. What we're doing is we're doing a program of dampers for Duramaxes that are front drive capable. By that I mean they have an 8-bolt drive system or bolt up on the front of the damper itself. And we're entering into we've had a long relationship with Horschel, the Horschel brothers, who manufacture viscous dampers for a lot of different engines,
yes.
Both gasoline and now diesel, for a lot of years. And they also supply dampers OEM to like John Deere and
so is this damper
Volvo
something
and others. The point being that I want to drive an external oil pump into the other end of the oil gallery of the engine to provide greater oil flow, so that I have idle and low-speed oil pressure I'm looking for. And I'm going to open up the nozzles even further for marine use, or probably for Bonneville, and that'll find its way back into the dragster engines too. The cool thing about this viscous damper program is we're entering into a relationship where all the performance dampers for Duramaxes will be designs that we do and manufactured by those guys to our layout. But we do the damper development here on our engine dynos. We basically measure the twist in the crankshaft with the engine running at different speeds and loads, and with different stroke lengths and different piston mass. There's a whole bunch of stuff you enter into to come up with what's called the mass elastic diagram of the crankshaft, the damper, the flywheel, the torque converter, or clutch, or whatever's back there. And then you come up with an initial damper inertial ring, and etc. And then you put it in the engine. You put a laser tachometer on each end of the engine, which gives you crank position. And we measure the crank twist, and they twist and then they spring back. By the way,
how much twist? Like when you're saying that it actually twists, I mean, 10,000s, 100,000s.
Well, you measure the twist in degrees.
In degrees.
Like crank rotation in degrees. So my ideal for a durability and long-term endurance engine is plus or minus a quarter of a degree. In shorter duration engines where you're really popping the cylinder pressure and very high speeds, especially with strokers, where the crankshaft gets fragile due to the stroke length.
Right.
And I'll accept a half a degree, maybe 5/8 of a degree, but those engines don't run that long. But the damper is mission critical. Guys with Duramaxes have been breaking crankshafts for a long time, and never blaming it. Let me check. Let me go back a little. We've held, the Pro Stock truck record for like 4 years. We were first into the sevens, and finally a 772 was our best pass, and that was back about 2009. And that engine made pretty serious power. It came out of a road race program I had with GMC, where we kept killing the transmissions and the rear ends. And I hadn't found a I found a good rear end solution, but I had some racing trans built. But in waiting for the transmissions, I said, let's take the engine out of the road race truck and put it in this Pro Stock truck, a little S10. And we went out and immediately started getting the record and then pushing it down, and then we stopped. And a few years later, Wade Moody, initially using some parts he bought from us, he got an S10, and then equaled and finally beat our record, which is cool for Wade.
That record seems to get chopped up pretty often. I mean, that record, like, everybody seems to be going after that quarter-mile-an-hour record. I feel like it's pretty often I hear about somebody new sitting on top of that pile.
Well, yeah. Well, the Pro Stock truck thing is kind of stopped. Wade crashed his truck. Mine's sitting in the NHRA museum for the last 5 or 6 years. And so, you know, it's kind of a cool little deal. I know if we actually had built a drag race engine, we'd have done quicker ET and a higher speed. Maybe one day we'll go back with an L5P based engine in that little truck.
Ooh, now we're talking.
But the point I wanted to make is all the records that we set. We had the best ET for a Duramax based race car. I think we're still second best at a 718 with our dragster blowing the transmission going into the lights. And then we rebuilt the transmission and backed up our run. And that's
awesome.
I think Comp Diesel has a listing of Duramax, quickest Duramax. It's somewhere out there.
Yep.
Yeah.
Yeah, I think we're still number 2.
Oh, wow.
We were on top of that list for a number of years with a thing that we broke. What I'm getting at is all that stuff was with stock crankshafts. We never broke a stock crankshaft, and we were the guys with the records. So I know we were, putting out substantial power.
A lot of the crankshaft
Why didn't we ever break a stock crankshaft? Well, we used viscous dampers that were properly tuned to the crankshaft dynamics. And everybody else doesn't. You know, everybody else tends to use... In fact, those 800-hour marine engines, viscous dampers, same deal. Same guys manufactured them for us. So
they're the ones to call.
Anyhow, what I'm getting at is guys are changing firing orders, trying to figure out why they're breaking the crank. And realistically, there might be a subtle difference there, but not a night and day difference. It's like changing a small block Chevy to an LS engine's firing order. That's the difference. That's how a small block Chevy fires the same cylinder sequence as a Duramax.
All right.
And the rearranged firing order that a lot of guys are selling with a camshaft and an injector rewire schematic is basically an LS firing order. But I don't know. In diesel, everybody has their black magic, it seems, and it's treated that way. But guys, it's that simple. Small block Chevy versus LS small block Chevy. That's the firing cylinder sequence. You can't compare firing orders because between engines because guys number the cylinders differently.
Right.
So you got to compare what I call firing sequence. In other words, you common up your comparison to the same. You know, I number all the engines I'm comparing my own way is what I'm saying. Then they're comparable easily. But the damper that's being used mostly on these racing or hot-rodded diesels is an aftermarket damper that uses O-rings for the elastomeric portion of the damper. Well, I'm going to tell you, I can't run stock elastomeric dampers, which have a lot more durability than this racing thing. And, the rubber overheats and you're done. But the other part of it is the tune of the rubber and the inertial ring mass on the damper to the crank, the mass elastic diagram of the crank rods, pistons, and all of that jive. What I'm getting down to, I'm throwing a bunch of buzzwords in the air, and I'm trying. I don't want to do that. I don't like grandstanding.
No. I hear you, though. I mean, it's a really important, I think, insight into something that we do get a lot of questions about, and a lot of guys calling and asking about, should I go to, like, how should I upgrade my crank is what I always hear. I want a billet crank. And
right.
There's some other opportunities out there. I think we also stumbled into
Here's the deal. When we were doing our damper solution for the L5P, maybe, I don't know, a year ago, we started on that. The whole deal was I needed a new solution because the crankshaft has changed so much. The crankshaft, by any measure, is 35% stronger. They've upped the cylinder firing pressure 20%, but the crank is another matter. I mean, that thing is. The main bearings are wider, by the way, due to the fact that they've rolled the fillets rather than radiusing the fillets on the crankshaft main and rod journals. This is something we did back in the early 80s when we were turbocharging the Buick V6s. That was a rolled fillet solution on the Buick cranks. So it's not new. What's new here is on the L5P crank, the shape of the fillet that is rolled in, or coined, as I like to say. They compress the metal so that you don't have a radius, you have a dip. You have the bearing surface, then it dips down, and then it rolls up into the crank cheek. Both on the mains and the rods. What that allows you to do is with the same journal width, you can have wider rod bearings and wider main bearings. So that's bearing surface area. They left the main journal diameter the same on the L5P as the prior engines, but the rod journal is about 200 thousandths bigger. I think it's about 5 millimeters bigger. My big pin cranks that I've been making are 3 millimeters bigger, but I wanted a lighter weight big end on the rod, and I wanted to run the bearing surface speed up to 8,000 RPM. On the new L5P, they are using a bigger journal, and of course, on the ones I've been doing and the ones the production ones, you can't get the rod with that bigger journal bearing. It makes the rod big end. If conventional rod and cap, the thing gets so wide you can't put it through the bore to assemble the engine.
Right.
So they angled the cap. I angled mine at 40 degrees. They angled theirs, I believe, at 45 degrees. Now with the cap off, the big end of the rod will go through the bore. Just like a Cummins. I mean,
it's same looking rod.
An angle cap rod is it's actually a pain in the ass to evolve and design and evolve and keep it round. And I spent 2 years on my solution. We created our own bearing size from scratch.
Oh wow!
What about the material and the hardness of the crank, Gale? Do you guys do anything on testing as far as the L5P crank compared to the LML?
The metallurgy of the crankshaft is proprietary to General Motors.
Okay.
The heat treat or hardening as well. But there's a fine balance. Oh, wait, let me finish telling you about that radius, that rolled fillet around the.
Okay.
It's not a radius. It's actually a J shape. It's a continuously changing radius. These guys did their homework on that crankshaft. It is stunning to me how much everything has changed. You know, I got a beta engine, so much has changed since the beta. It's amazing. And my pre-production engines, they ran about 150 pre-production engines end of June. I was there for that, and we got, I think, 7 or 8 of them. So we're doing our development on engines that are basically identical to production, our final development.
So you're not going to be trading your L5P in for an LML?
Other way.
Well, you know, the LML is a pretty damn impressive piece. We're building the first week of July. We made a buy of nominally 2,100 LML long blocks built to our part number. In other words, those are for our military, our pilot production of military engines. So we're going to be doing nominally 2,100 LMLs. We're at engine number 100 as of last Thursday, and that gives us a little cushion to get the L5P totally dressed, totally worked out, because we're changing the lower sump, you know, the crankcase, the lower crankcase, which is aluminum, the oil pan, and all that jive changes, and as does the flywheel housing. You know, it's got to be
to fit up in that
SAE bolt pattern.
Yeah.
So yeah, the customer is Oshkosh Truck.
Mm-hmm. Gotcha.
Yeah.
Well, that was
JLPB.
That was some great information, Gale. And after one more quick word from our sponsors, we're going to be right back to talk a little bit about dynos.
We're breaking new ground in the turbocharger market with our Stealth series. The Stealth 64 is a perfect replacement for any stock turbocharger on any year Duramax. The 64mm compressor wheel adds at least 80 rear wheel horsepower on a stock fuel system while maintaining stock drivability and excellent spool up. The Stealth 64 also helps maintain lower EGTs under heavy loads, especially useful for you guys pulling. If you're looking to upgrade or replace your stock turbocharger, check out the Stealth 64. Perfect balance between power and drivability in a drop-in, stock-appearing turbocharger. For more information, check out DuramaxTuner.com or give us a call at the office at 815-568-7920.
All right, and we're back. Me, Nick, and Danny are here talking to Gale Banks. We've been through a plethora of great details about diesel, about the L5P. We've really got a chance to dive into it, viscous dampeners and all. And we're back, Gale, to talk a little bit more about dynos. And Nick, I'm going to let you go ahead and dive in right here and kind of get started with framing up what we had some questions about.
Yeah. I mean,
okay, Nick, as you get into this, bear in mind, guys, there's a boatload more L5P, the whole upper end and induction system and all of that.
yeah, I mean,
we're probably going to reserve it for another time. But there's much more L5P to talk about. So let's talk dynos.
Let's talk dynos. Yeah, so it suffices to say that the basement of the L5P is a beast, and the top end, I think we can leave that as bait for our next one. I mean, there's a lot more to talk about there.
I like it.
Well, and I'll know a lot more about modifying it. I put it on my Facebook. I think it's Gale Banks Turbo or Banks Power.
Banks Power.
There's two of them. We've got two Facebooks. I put up some photographs of a prior, probably an LMM cylinder head and the L5P head. I'm just looking at the intake ports. It's mind-numbing, the difference in appearance of those things. So.
Yeah.
Enough of that, though.
That's a whole another episode right there. Absolutely.
Yeah, I mean, you know, last time we spoke, Gale, we kind of went down a little rabbit hole about the mad versus bad, about, you know, what is the story, what's the true story that the dyno test tells, and, you know, there's a lot of information sources out there, be it the forum or magazine pages or videos, YouTube, whatever you want to look at. We got a lot of listeners to the podcast and viewers on our YouTube channel who don't have the experience that we have operating a dyno, seeing seeing how a dyno works, seeing what the inputs are, what the outputs are, what the variability is. Really understanding what goes into a test and what goes into designing a test. And I know I read through the forums and I watch YouTube videos and I see dyno tests, and I mean 8 times out of 10 I just cringe. I have a hard time watching that stuff. It's just I feel like the way the dyno movement is going is it's a trophy. It's a trophy number, and the tool and the ability to use the tool to really define the potential of the engine in terms of not only power but reliability it's not being spoke to.
Well, I would agree with that. Here's the deal. The dynamometer is supposed to be a tool to develop an engine or an engine and powertrain, if it's a chassis dyno, for a specific use. In other words, if you're going to do a truck pull, then you want to duplicate that load and the RPM change, and maybe even the gear change if you make a gear change. I don't think many guys do. The point being, the dyno is a test of what the engine or vehicle might do when you go out and compete with it.
Yeah.
The dyno is not, in and of itself, a test for a dyno. In other words, what we see at the fairgrounds or wherever is a guy coming in with a dyno built into a semi trailer, so to speak, or a pull-along trailer or a fifth wheel or whatever the heck it is, which is a big rolling inertial weight. In other words, you put the drive wheels on top of this hopefully 4 or 5 foot diameter roller, which roughly doesn't even roughly approximate the surface of the Earth and the flatness of the surface of the Earth. But these guys only run a run of 2 or 3 seconds. It isn't an off-idle run. They get the thing up, they get the thing rolling at some speed, and then they nail it. There's no load control on it. In other words, it's you just accelerate this big drum, this big inertial flywheel. And the rate of change of the speed, by measuring that, you can compute the power required to make a change speed from one speed to another as you accelerate the vehicle. But it never stops you and makes you cook at any particular RPM. It never duplicates anything that is directly proportional to the vehicle because the weight they're accelerating is nowhere near the inertial weight of the vehicle.
Yeah, exactly.
So it's just a common thing that guys can get on and accelerate and compare the power over a 2 or 3 second span.
Well, let me play devil's advocate here, gentlemen. Okay,
All right,
Mr. Two Dyno experts. If I go to the fair and me and Danny both bring our trucks up to the same
Danny
dyno,
and I.
Thanks for joining the
Please
episode.
continue.
Yep.
Danny and I go to the dyno. He rolls 500. I roll 600. My truck makes more power.
Yep.
I don't care about anything else. Like if I'm at the dyno, I'm at the dyno. Like I don't understand what brakes or why the inertia dyno would be a problem. If I'm there just to measure the peak power of the truck, aren't I getting that?
So did you build your truck? Under what circumstance, Paul, do you use your truck to accelerate from 60 to 120 in 3 seconds?
Oh, okay. I mean, I guess the only scenario would be on the dyno.
Maybe a burnout.
Yeah,
Maybe.
it wouldn't even
60 to 120. Yeah.
If the inertia of the dyno and the inertia of the truck, the mass or weight matched, then it would probably be a pretty close comparison to accelerating the truck on the ground. But my point is, I use a dyno to develop a racer or a marine engine or a military engine. And then you go out and you race somebody. That's the end result of the dyno testing. It's not a test.
For a test's sake?
Well, it's like...
You're aware there's competitions now,
Gale Banks is calling out all the Dyno-Queens in the country right now. I
can't say what I'm thinking. But it's like a pissing contest.
Yeah.
Was it dick measuring
all right.
contest? Is that what we were alluding to? Can we just say that?
Yes, that's what
we were getting to that.
All right. You got close.
We're a little on the nose, yeah.
You're close, but no cigar.
I think what Gale's getting at is that the test does show the horsepower number. It does that,
Hell
right?
yeah.
But it does. It
Yes,
does not.
it does, and it's like going to the county fair and hitting the thing with a hammer and see if you can ring the bell.
Me and Danny did that too, and I won that one too. Yeah, I know.
Danny and I did that, and I wasn't hanging out with you.
You guys got to take this outside.
Oh, we've got it in the battles. You guys talk about no man's land and other things that we've already talked about a little bit on the episode here today, and I'd love to.
I think it's
dig
kind
into
of
that.
fun to go out and do what the guys do. I want to bring it. Let's race now. You know, you just ran 3,000 horsepower and went nowhere.
He's laughing at him.
I love it. Well, it is. It brings us back to that conversation we have all the time on the show about form. You know, function over form, right? Like, if you're going to build a truck, have a reason you build it. I think it's okay if you just want to build a Dyno Queen. I don't think it's cool, but it's okay. It's morally sound.
As long as that's what you're doing, right?
Right.
As long as that's what your purpose is, then, you know, if that's your thing to put a horsepower number up, then, you know, that's what you're going to do. If you're going to use that horsepower number to pull,
it's a good and interesting contest. That's what it is.
That's why the UCC is such a big deal, because these guys are dynoing and then going out and competing against each other. So then they're validating everything on the dyno, I feel.
Yeah. Well, I feel like the other competitions, they measure the driver, right? They measure the truck as well. Like, you got to have a truck to compete with, of course. But
Hell yeah.
There's a lot of driver error that we see in big competitions.
well, let's not leave the crew chief out here. Right. Okay, we got transmission, rear end, tire. I mean, there's a lot of setup that goes into putting a truck down the track, and you know, dyno numbers is a small part of that.
Yeah. Okay.
Different strokes for different folks.
Hey, that's why jelly beans are different colors. Something for everybody.
Yeah.
That's what my grandpa always told me.
At the end of the day, the engine goes in a vehicle that does something. That's much more challenging than 2 or 3 seconds and going nowhere. So maybe I'm just more complicated. I don't know. But I mean, you guys go out and you pull.
Yeah.
You know what it's all about. It's now the person is part of the final contest outcome. I like that. I like to load the gun for my driver. You know, I often argue, you know, every record and every championship and that we've won, whether it's offshore racing in boats or drag racing or Bonneville or Pikes Peak or whatever it is, diesel, gasoline, I don't give a damn, as long as it goes bang. But I always argue the chassis prep, the engine, all of that stuff, if you get it right, if you load the gun for your driver, and he can do it skillfully, if you don't load the gun, he can't hit the target. That's my point. Mm-hmm. Unless he's Parnelli Jones. and Parnell Lee Jones could drive junk and win with it. but I mean it. I mean,
Is he
really,
sitting in the room with you, or are you just paying a compliment to the guy on the other side of the window?
He's buying me drinks tonight.
Oh.
But what I'm saying is, I love the full-blown aspect of it's the engine, it's the tranny, it's the axles, it's the suspension, it's the weight distribution, it's the intercooling, it's all the stuff, and it's the guy driving it.
Yeah, it puts the whole picture.
Now you got something. Now you did something. You didn't just put up a number. You actually took it. I often wonder, those guys actually pull with those trucks, or what do they do with them?
They're being forced to. The ultimate call-out challenge, like Danny said. That's your next event, Gale. By the way, the competition of dyno numbers, both horsepower and torque combined, and then you have to race the truck and you have to sled pull with it. Not that those are the only two things you can do with the diesel truck, but it certainly forces a wider picture, wider lens on the thing.
They're certainly the two
So
coolest.
where's the next one going to be? April 21st through 23rd.
Boom, Indianapolis.
Indy,
So excited.
baby.
That's right.
I'm going to be there next week.
Oh. Get your
What are you
hotel
doing out in
room.
Indy?
Yeah.
Going to PRI?
I'm doing the Advanced Engine Technical Conference, ATEC. I'm one of the speakers. It's put on prior to the PRI show at Indy.
Cool.
It's a 3-day show. It's a 3-day series of guys that are in my business telling about something new technical developments, what have you. I think it costs about $500 to attend it for the 3 days, and I'm just guessing at the price. It's around there. And then guys like me come in and provide the entertainment for free. Somebody's making money.
Somebody's making money here. I don't know who.
Yeah.
Somebody's making money.
But this has been going on. I've done this before. It's a very cool thing to do. You were mentioning mad and bad, and mad to me is manifold air density. It's what the job of a turbocharger or supercharger or an intercooler is to make density. They're density machines.
Mm-hmm.
So I've come up with an instrument and data logger that's all in a 2-inch gauge. It goes right in a gauge pod that measures the boost air density, which is let me tell you what density is. Density is a measure of the weight of air per cubic foot. Engines process cubic feet of air. In other words, they pump their own displacement every 2 revolutions of the crank. So if you've got a 6.6 liter engine or a 6.7 liter engine, that's what it pumps every 2 revs. Throttles, superchargers, turbochargers, intercoolers are all control the density of the air, the pounds of air per cubic foot going through the engine. And you got to have pounds of air to mix pounds of fuel with in your air-fuel ratio. So if you're going to make power, you got to have air density. You can also turn up the engine RPM, and that'll process more air. But
To a point, right?
it's all about how much air density, not how much air pressure you can get into the intake manifold. So, and then the measure of your, if you will, supercharging system is called BAD, boost air density. So ambient air density, AAD, is add. MAD is the manifold air density you got in the manifold feeding the intake ports. And BAD is the manifold air density minus the ambient air density. That's bad. That's badass, to tell you the truth. The bigger that bad number can be, the better it is. So a boost gauge gives you about 1/5 of the information that you really need to know what the hell you're doing. In other
but
words,
it moves a lot, so I like to watch it.
Tell him what he's missing,
and
Gale.
and so does this.
Okay.
Yeah.
As long as there's activity, something shiny.
Yeah. Well, okay.
This
Here's
is your
the shiny
customer.
fishing lure.
This is your customer, just so you know.
Do you like the color?
I do buy fishing lures based on which one I think I would eat. I'm just telling the truth.
Anyhow, on the dyno, we can duplicate a drag race run, or we can duplicate a pass at Bonneville, whatever, and we actually run the vehicle as if it's on the race course, and we measure the response of the boost air density. How quickly is it coming on? We can measure also, big intercoolers like air-to-air. The more aluminum you've got, the more thermal capacity the thing has. If it's also filled with water, a water-to-air, then you've got the thermal capacity of the colder water. So there's two factors in an intercooler: the thermal capacity of just the material and the water, let's say, that's in it. And then the other part is the rate of heat rejection. So when you start out with a cold intercooler, it's absorbing a hell of a lot of heat because you're heating it and it's transferring heat to the air or to the water. You can watch all this happen by measuring boost air density. You can watch it happen. By the way, an intercooler improves density, but it reduces boost. You lose boost through an intercooler. You guys are all aware of that, right?
Oh, it makes sense.
Yeah. So you put in an intercooler where you didn't have one before. I've done that back in the day. And your boost gauge is hooked up to the intake manifold, and you just lost boost. It's like
Paul takes it back.
Now the boost gauge is
I totally would too.
Yeah.
Fucking intercooler then.
So what's the intercooler doing? Well, it's increasing the air density. It's cutting the temperature, making more pounds of air per cubic foot. That's what the bottom line is.
Okay, so let me ask this, Gale. Real quick, let me ask this, Gale. So if I'm now watching my bad sensor instead of my boost sensor, okay, and
right.
I'm seeing a problem, aren't my diagnostics more complicated because this is calculating more potential factors, right? So there's more inputs. So that means if I see a low bad number, I have a lot more potential problems as opposed to like low boost. There's probably, off the top of my head, there's probably 7 or 8 possible things that could drop your boost. It sounds like for my bad sensor, there'd be like 20 things that could drop my bad sensor.
This little 2-inch gauge that I've done has a 1.8-inch flat screen on it. And I can give you your boost reading and your bad reading and your ambient reading and your manifold density reading and whatever else you want.
Yeah.
So
we run through
you're not losing one to gain the other is my point.
Fair enough. It's badass. You got me.
Yeah, so I mean, Paul, a typical situation we run into troubleshooting diagnostics is boost leaks. We see boost leaks on probably 80% of the trucks we bring through here in dyno tests. We boost test every one of them. Boost leaks, right? And the customer... It
is kind of interesting. The boost leaks occur and guys don't even know it.
No,
never.
Cannot happen to me.
Not my truck.
That cannot happen to me.
I just did a filter.
Right.
That's my favorite response.
Yeah, I tightened that clamp.
Right.
But I mean, we would normally see our boost number maybe at peak. There'd be no fluctuation, right? So it made 45 pounds before. It still makes 45 pounds of boost. Can't have a boost leak. Well, your bad number's down, right? So
I like that.
There's your indicator.
Both down. Boost is down and bad is down.
Yeah.
So here's the deal. With another sensor, we're doing a combined temp and pressure sensor. So you could have one before and after the turbo and one before. Your after turbo would be your intercooler in, and then intercooler out. I see a lot of turbo compounds where there's no intercooling between the atmospheric turbo and the high-pressure turbo. No intercooling at all.
Yeah, we never.
Man, are they leaving a lot on the table, but they don't even know it.
There you go, Paul.
You could find you could find that. This is, if you're into diesel, this is the tool. I originally did this at Bonneville back in the 60s. I was hand calculating what was going on. Then a guy named Dean Moon came out with an air density gauge that we all used to jet our carburetors and screw around with stuff. But I started doing ram air in 1960, cold air rammed. I took a headlight out of my Studebaker, my 53 Studi, which ran back then 189 miles an hour, so it was a C-gas record holder. And with a Chevy, a little small block Chevy in it, injected. Point being, I picked up so much speed by going to ram air over no ram air. I wondered why, how did I measure what that did? And I took the ambient air density gauge and put it in a box with a pipe leading to it from the ram air inlet. And I was able to measure the difference between ambient, which I did just sitting there, and then at 190 miles an hour. And I picked up 0.61 pounds. This is the first time I ever looked at density. I picked up 0.61 pounds. That was 24 horsepower.
Holy shit.
This is on an injected small block Chevy. And I just kind of went, I'll take that. It didn't give me the 200 miles an hour I was dreaming about, which would have got me in the 2 Club at Bonneville, which was a big deal in 1960-61. But my point is, I've been paying attention to manifold air density ever since.
Let me play devil's advocate here. What about the mass airflow sensor?
Mass airflow sensor is the other part of the equation. If you increase your manifold air density, your mass sensor will the reading will increase.
So what do I get from my what do I get from your gauge that the mass airflow sensor is not telling me?
The mass air sensor doesn't give you all the elements. In other words, what we're really sensing is humidity, pressure, and temperature. So we can tell humidity you're kind of stuck with,
right?
Unless you're water injecting. Mm-hmm. You're stuck with what nature gives you that day. But temperature and pressure, did I drop the temperature or increase the pressure to get that mass airflow sensor to respond?
So more granular. Yeah, I see what you're saying. More granular data set. Okay.
Yeah. And it's an active, it's like a batting average. In other words, a standard day, when you're dyno testing, you correct to a standard day.
Right.
That way you can compare your engine dynoed in Denver with one dynoed in San Diego, California. But you're correcting to a sea level day. That's the old axiom. So in racing, NASCAR, ourselves, we use J607. That's the SAE standard, an older one. On that day, it's 60 degrees Fahrenheit, and the barometer is 29.92 inches of mercury, which is 14.7 pounds of air pressure, and the humidity is 0.
Right.
When if you dynoed on one of those dynos, say the event was in Denver, I could give you the correction factor reading the system in your truck up on that dyno that would give you the sea level power. So let's say you made 2,800 horsepower with this, a correction factor that would bring you to sea level. So now you've got a comparative. The thing that's cool about MAD is a real good naturally aspirated engine. If you hit 100, in the 100% MAD, that's pretty damn good for something you're driving on the street.
Yeah.
If you hit 200 and you're burning gasoline, at 20 pounds of boost on any engine, you're not going to hit 200. You're not going to double your air density,
right?
Due to the heating. If you're not intercooling, I'm saying just a straight up turbo.
Right.
All I'm trying to get at is it's like a batting average. Diesels, you're from 200 to 300. It would be the range of a street driven hot rod diesel.
Mm-hmm.
If you get to 300 and you're playing baseball, you're pretty damn good. And if you hit 400, you're a god. And the same thing goes with manifold air density. It's like 200's respectable, 300 is, oh my God, and 400 is you're bound down to that. It's just so. And you can unlike a boost gauges do not account for ambient air pressure.
Right.
So 20 pounds of boost in San Diego gives you more air density than 20 pounds of boost in Denver, and especially 20 pounds of boost at the top of Pikes Peak.
Yeah.
Engines, when the piston drops down the bore on the intake stroke, it forms an almost perfect vacuum in the cylinder. What you care about is any pressure above ambient. In other words, manifold air pressure, MAP sensor, is very important, not boost.
Yeah.
If you're going to
now, if you could just get that sensor
measure anything, you should be measuring MAP. And all I'm saying is a boost gauge is terribly flawed because it's a gauge pressure. It's a pressure above ambient. If your ambient is 14.7 pounds in San Diego and 8.8 pounds at the top of Pikes Peak, you add both those numbers at those locations to your boost number, and now you've got the pressure number the engine really cares about.
Mm-hmm.
So the guys in Europe rarely talk about boost. They talk about bar or KPA or total pressure,
Right.
starting from a vacuum. The boost gauge ought to be outlawed. Use them for measuring fuel pressure or oil pressure. That's where they belong. They belong in the 19th century.
Yeah.
They're Stone Age.
So your gauge reports in what? It's just a percent, 100, 200, and a percentage?
Yep.
Okay.
100% is 76 pounds of air per 1,000 cubic feet, by the way. So for you, the air fuel guy, you can predict your power output from the reading as well. So in a gasoline engine, 10 pounds of air is 100 horsepower. So I've got to calculate the diesel equivalent for my torque. I just realized that.
Yeah, but
because the diesel air fuel ratio is different.
I mean, if you have this gauge and you're picking up let's say you got RPM and engine displacement, I mean, you guys should be able to display a theoretical crankshaft horsepower number, assuming stoichiometric, or assuming.
I intend to.
Yeah.
Well, if you know your power at any MAD point, in other words, you go on a chassis dyno.
Yep.
And you baseline the engine, you measure the manifold air density, you've got a starting point. In other words, let's say you're reading a 200 MAD, and you go to 300. That's going to increase your power by 50%.
Right.
Actually, it's a little bit more than that because you don't increase the viscous and frictional and thermal loss. But all I'm getting at is it's a damn good indicator of power, but you need a reference power number.
Sure.
Once you've got that, I've got 4 buttons on this gauge so you can put data in or take data out. And I got a little micro SD card slot in the face, so you pop it in and you data log all the stuff you want to data log. Not just mad and bad, but everything, RPM, throttle pedal position, whatever's on the CAN bus in your vehicle.
Sure.
I plug into that as well. So
Cool.
it's a pretty cool little deal. Nothing like this exists. I call it the iDash, little I, big DASH. C2I is C2I stands for command, control, and information. So
Nice.
it's a pretty cool deal that we're using. We're using, like a buddy of mine's building a Volkswagen drag race car that uses big block Chevy pistons in a Volkswagen 4-cylinder engine. You figure that out. And he's way over 1,000 horsepower right now out of 208 cubic inches. And after I come back from PRI, we're going to stick this system in his vehicle for him just to develop the turbo and the intercooler and the boost response or density response and all that jive.
Yeah.
I'm off on a tangent.
No,
We were talking about dynos. So bottom line, there are 3 types of dynos. There's the inertial chassis dyno. There's a load capability chassis dyno, which is the one I prefer, because you can cook it, you can do accelerations, you can actually, it's the best place to do fuel economy because the weather conditions don't change. No headwind one day, tailwind the next. The traffic patterns don't change. What we do is we map it out. We go out and data log a driving profile of throttle position and acceleration, all that jive. We write a program for the dyno to duplicate it, and then every time you drive for fuel economy, it's exactly the same drive. And then what you do to adjust or improve fuel economy, you can validate. Dead bang. We've done it on Class 8 semis.
What would a fuel economy test be without some bias? I mean, they got to have the driver in there. I love it.
It's really close to what they did at Diesel Power Challenge. Remember, Danny, we were talking to KJ about that, and they had almost exactly what you just described, Gale, was for the Diesel Power Challenge this past year. They put them on a dyno, they strap them down, and they have like kind of like a level, so there's 2 lines with a bubble in between it, and you have to give your truck enough throttle to keep that bubble in between those 2 lines the whole time. So they change the load, they simulate the grade, all of that, and that's actually how they came up with their fuel mileage test this year. And
they're
said
running
it was
an
super
emissions
accurate.
test.
Yeah,
they're running an emissions. That's an emissions test.
Okay.
And you can drive fuel economy out of that. We created the same test for a Class 8 semi. There is no such test, but we got the aero data and the weight of the vehicle and all that, and we just amped up the emissions chassis emissions test for a pickup truck to Class 8 size, and boy, it's damn accurate. I got guys here who can drive that bubble like you can't believe. Really, I mean, they're deadly good at it. You go outside the lines, you scrap the test.
Oh.
So, but built into that is the fuel economy testing. We add the US06, which is the, we do the FCP, Federal Test Procedure. Mm-hmm. We do the US06, which is much higher speeds and loads. And there's one other test that we also add in. So you got all kinds of driving conditions mixed in. Like you're pulling a grade with a heavy trailer, like you're running high-speed light, like you're popping around town, that kind of jive.
Yeah, I mean, bottom line on this thing is that the dyno with the brake on it or with the ability to do these simulations is far superior for our application.
Oh, yeah.
I mean,
yes.
There's no drum out there that weighs,
If you're really serious about developing an engine for any use, you're on the engine dyno. That's where you can really exercise it. What happens on a chassis dyno is tire temperature.
That's what we're always
the
fighting.
roller,
is you just
the
can't.
roller is the radius of the Earth is like 4,000 miles, and the radius of the roller is like 10 inches. So you're putting a pressure wave in front of the contact patch. In other words, your tire is really upset at the tread surface, and the faster you go, the worse it gets. And if you run them, you can't run a 33-day test on a chassis dyno at full power. You killed the tires about 30 minutes into the test.
Don't tell me what I can't do, Gale. We have a chassis dyno here, and it's Nick, so I don't care if it breaks.
Literally got lugs laying on the back of my chassis dyno room just from people trying that.
Well, you know what I did is I got two absorbers on mine. So mine's a 1,500 horse, 200 mile an hour, 33,000 pound maximum axle load. It'll do a lot, and it's two big like electric power absorbers, and I air cool them. I put huge blowers on the wall behind the dyno, and there's a total of 10 8-inch pipes, 5 from each blower, that cool the absorbers and the tires. So, and we also watch tire slip versus tire speed versus roller speed.
Mm-hmm.
The two of those lines have to lay on each other all the time. It can't be slip. And what's the other thing we do? Oh, yeah, we have an infrared pyrometer. We're watching tire temperature as well. So we literally can run for days on a chassis dyno.
That's awesome.
Yeah. I do a lot of motorhome and work truck stuff beyond pickups, bigger stuff.
Yeah.
You wouldn't think it. We don't talk about it much, but those big diesel pusher motorhomes, we do a lot of that stuff.
Oh, man, those guys are a nightmare, though. Who wants to deal with them? No, I'm just kidding. Some of our best customers are those guys. You just got to give them a hard time.
You know what? You got guys out on the highway. Still, there's some World War II. There's guys that went to Korea. There's guys from Vietnam out there driving those things. And when they come into my shop, I can't talk to them enough. You know what I'm saying?
Yeah. You definitely marry those customers.
Yeah.
I used to sell RVs.
Yeah.
I know all about it.
That's where I get to meet the old vets and really hang with them.
True
it's
story.
Pretty cool in my book.
Yeah, absolutely.
Of course, I'm an older guy. What the hell? So for dynos, there's all types, but you can compare them. People say you cannot compare dynos. Yes, you can. If your dyno, first of all, the load cell has to be calibrated. The thing that reads torque has to be calibrated. And you have to honestly correct to the same standards. It's like when we did the deal with Cummins on that first common rail, there wasn't even a common rail in a truck at the time. You couldn't buy it. So, we got lab engines that were worn out and rebuilt, ring, valve, and bearings type of thing.
Yeah.
And we went racing with them. They built one, a pre-production engine at 402 horsepower with a 40 series Holset turbo on it, which they use 35s in production. Sent it out here. We put it on our dyno, and we measured 404. We were within 2 horsepower of the guys at Cummins. We've also had a similar chassis dyno comparison with a Ford 6.7 diesel V8. That thing came out originally with a lower power, and then GM came out with the Duramax and topped them. And Ford had a hole card. They already had a calibration and an emissions legality on a higher rating. So then you could go to the Ford dealership and get a reflash, and it would bring your power and torque up. You guys remember that?
Oh, yeah.
So pickuptrucks.com brought a Stalker 6.7 over here, and we dynoed it. They went to the local Ford dealer, got the reflash. We dynoed that. then they sent the numbers to Ford Motor Company. I didn't know about that, but it was kind of cool because it came back through pickupstrucks.com. A casual comment from Ford was, "That's just the numbers we got."
Yeah.
So I thought, well, there's a comparison from our chassis dyno to Ford Motor Company.
You're talking about two
If
companies
you
that
do
take
it
their
right,
stuff
it
seriously.
is comparable. But guys change the correction factor. They diddle the numbers, and they give you readings which are pie in the sky.
They make customers happy, Gale. I don't.
Hell yes.
They make customers happy. They
I
never
went over.
publish stock numbers.
I went over to Danny, and he dynoed my truck, and I got 612 horsepower. And then I went to see Nick. I got 630. Went over to see Paul. That thing went over 7. I'm going to go to Paul.
That
700.
It's so accurate of
Paul's
how it would
numbers are
actually go.
That's exactly how it works. That's exactly how it works.
I'm just better at operating a dyno than the other two, is what I heard.
I'm just happy to make some numbers.
There you go.
Gale,
Yeah.
it's been such a pleasure talking with you. I feel like we've gotten so much information and so much time out of you. Really, thank you so much from the Diesel Performance Podcast.
For sure, man. For sure. It's been fun. I mean, I'm
This is
excited
an
for the
enjoyable
dyno.
thing to do with you guys.
Well, guys, this has been Paul Wilson.
I'm Danny Voss.
Nick Priegnitz.
Thanks for listening.
Calibrated Power Solutions, the leading North American developer of clean diesel power and home of DuramaxTuner.com, is the proud sponsor of the Diesel Performance Podcast. Calibrated Power develops emissions-equipped tunes for a wide variety of diesel powertrains, including the Duramax, Cummins, Jeep, John Deere, and many more. For more information and the best customer service in the industry, check out calibratedpower.com or call 815-568-7920. That's 815-568-7920. To reach out to the Diesel Performance Podcast, send us a message through Facebook or email Paul at DuramaxTuner.com or Danny at DuramaxTuner.com.
Okay.
Different strokes for different folks.
Hey, that's why jelly beans are different colors. Something for everybody.
Yeah.
That's what my grandpa always told me.